Okay, we're going to learn how to do an antiderivative. Okay, so you have to think about like when we had something like this, that how did we find the derivative? We did k times n, and then here we went n minus 1. So we had a 6 and an x. So how can I go from here back to the original? So that's what we're trying to do today with the antiderivative. Okay, so the first step is to say that if I ended up with an x, I obviously started with an x squared, and then what did I need in front here? So 2 times k, 2 times what would have given me the 6. So therefore there would have been a 3 in the front. Okay? Okay, so I'm going to represent the original with a big F if this is a little. And then if I think about this first one, it would have started with an x to the 5th. So what times 5 would have been a coefficient of 1? So 1/5 times 5 is 1. Okay, so this one would have started with an x to the 4th. Now, what times 4 would give me 7? So what times 4 would give me 7? So then it would be 7/4. Okay, the next one is, it would have started as an x squared. So what in front times 2 would have ended up as an 8? So this one is easy with mental math. And then if something ended up as a constant, it would have had an x, right? Because the derivative of this is 7. And then we're going to add a plus c at the end because we don't know if there was a constant like a plus 15 or something like that at the end. We don't know that because when you derive it, there is no derivative for it. It's a 0. Okay, number 2. I'm going to rewrite it. And then this I'm also going to rewrite as 1/7. Okay, so what is the antiderivative? So what is the original? What did it start off with before I derived it? So this would have had an x to the -5th, right? Because that's 1 higher. Now, what would I put here to multiply to 3? So -5k would result in a 3, so k is -3/5. Okay, next would have started as an x to the 5th, 1 higher. So 5 times what coefficient would have resulted in a 1/7? So if you divide this by 5, you would get 1/35. And then again, you need to have a plus c at the end. Okay, next. In order to end up with a sign, your original would have started as a cosine. Okay, so let's just do a trial. If we started with a cos 4x and we derive that, how do you derive a cos function? So it's negative sine of 4x and then times, and then you would also have to do 4. So this would have resulted in that. So if you started like this, you would end up like this. It's close, but I didn't want that part in front. So therefore, I would need something in front to counteract that. So then I would put a -1/4 in the front so that it would multiply to 1. And again, a plus c. Okay, so here is an e, so I have to think about the rules. E, so when you do the derivative of an e, you just repeat it, and then times the derivative of the u piece, So let's do a trial here. Like, what did we potentially start with? So let's just say we started with an e to the 8x. So if I derive that, I get e to the 8x times 8. Okay, now let's look at this. Okay, I'm really close, but I ended up with an 8, but I only wanted a 4. So therefore, I will need to put a 1/2 in the front. Okay, next. I thinking that I did a power chain rule. So I can see that I probably started, right, an exponent higher. Okay, so let's derive this. If we started with this, we would get 2 of those to the 1 times the derivative of this. So this would be 6x squared. So if I start with that, I would end up with that. And we are awfully close, except for I ended up with a 6 and I want a 30. So therefore, I would also need a 5 in the front.